Hello friend, how are you all? So hope you all are fine. So today we'll continue with the polynomial regressions. So till now we completed up to multiple linear regression. Okay, and let complete that polynomial regression. So first of all, let me revise. Okay, so that it will be again revise that previous concept. Okay, shortly let me just revise. So as we let continuing what the linear regression part. Right now, we are just discussing all about the concept called the linear regressions. So here linear regression is of how many types? Yes, one is the simple linear regression, and next one is the multiple linear regression, and next one is the polynomial regression, right? Polynomial regression. Remember one thing, you can also call it as a, you can also tell it as a polynomial linear regression, you can also say. Because here linear regressions are having three types. One is the simple linear regressions, SLR, another is the multiple linear regression, MLR, and then next one is the polynomial linear regression, one is the PLR. Clear everyone? So here, whenever just we are coming to that simple linear regressions and we're coming to what, so let y is equal to mx plus c, or else you can say that, okay, so y is equal to, so beta 0 plus beta 1 x. Clear? So here this part is nothing but what? This part is the intercept part. This part is the intercept part, right? Intercept part. And here, this part is nothing but what? The slope, you can say. The slope. And here, this x is nothing but what? Data point. Okay? So here, listen. Or you can say the feature. Or you can say the features, or you can say the attribute. Okay, attribute means like in simple linear regression, so the data set will be like this. Means one independent variable, another one is the dependent variable, right? So this one the thing. But coming to why we're just moving towards the multiple linear regression, because in the simple linear regression, so we are having only one attribute, only one feature. Okay, only one feature. But point is what, if we are facing multiple feature, then what will be happen? Then it will be what? It will be continuously increasing. Yes or no? Means it will be looked like this one. Means like y is equal to beta 0 plus beta 1 x plus beta 2 x2. Like this it will be moving. Yes or no? Till how? Till Pn xn, beta n and xn, you can say. Okay, beta n, these are the beta. Okay, don't be confused. Beta. So you can just take any symbol. Okay, I'm just taking the beta. You can just take anything. Okay, so here multiple linear regression concept came because of the number of feature which is increases, not number of output. Okay, the output is same, but the output is totally depends upon number of feature. Here the single output which is depends upon the single feature, right? So here the concept will become, right, like for example in the simple linear regression, whether that person is eligible for that driving license or not. In that case only, so the age will be there, and the like either means in the binary case, either if the person is eligible or not, we have to just write in yes or no format, right? But that person which is suffering from the heart problem or that suffering from the any problem like health related care issues, okay, so that problem is nothing but what? So here the multiple feature will become like what is the blood pressure, what is the cholesterol level, okay, so all these things you have to measure, then after that you have to show that whether that person is suffering from the disease or not. So that is in that case only we will just move towards the multiple linear regression. Now, new concept is coming, that polynomial regression. Then in this class only, we will just discuss all about the polynomial regressions. So let's start the polynomial regressions. Let's move towards the polynomial regression. Now, if you will just look at that the graph of the linear regression. So while explaining this concept, I need to take the example of that simple linear regression so that it will be very clear. Okay, so I'm just drawing the two graph. So here only, so you will just get idea. Okay, so this part, the polynomial regression is what? First of all, before it, the simple linear regression in that first case, if the data which will be the data point which will be plot like this, okay, with the help of this scatter plot, then we simply just say that, okay, so this graph is nothing but what? This graph is the linear regression, means simple linear regression. Simply we are just drawing because our aim is what? To draw the best fit line, and this one is the best fit line. Yes or no? This is the best fit line, right? But have you ever think about like the problem like yes, no problem. This is the linear case, okay? This is all about the linear case. This is the linear graph, right? This is the linear graph. Linear, okay, linear graph. But what about the non-linear graph? Have you ever think that? Yes. Have you ever think that? What about the non-linear graph? So the non-linear graph. So here, if you will get non-linear graph, then the concept is coming. What? That one is the polynomial. So here polynomial is there. Who will just say that, yes, I'm here to handle the non-linear graph. It's like the graph will be looking like this one. Okay, the graph will be looking like this one. For example, this one. Okay, right? So this is the polynomial. Means let assume the graph which is not linear, not linearly it is what plotted, right? But in this case, what will be happen? Listen, what is the polynomial? So let us understand the mathematically. Okay, so in our class 10th, okay, so what we'll understand here, the polynomial is nothing but what before it. So we are just learning about the linear equation, linear equation. Then in the linear equation part, what? The highest degree. We are just coming to the degree part. Okay, the degree. The degree is what? The highest degree is the 1. But if I are just moving towards the quadratic, what is the quadratic equation? The quadratic equation is nothing but the degree is what? Degree is the 2. The highest degree is the 2. So now the question is coming, is every linear equation is the quadratic equations? Yes, because inside it, the quadratic equation having also a x also. It may or it may not be, right? But now the question is coming, right? The cubic part, the cubic equation. The cubic equation having a degree is what? Obviously 3. Similarly, if you are continuously increase the degree, then it will be converted to the polynomial regression. So now here the linear, the quadratic, and the cubic all are the indirectly also known as the polynomial part, right? This is also known as the polynomial part. Let's come to the machine learning now. So this is the mathematical concept behind of the polynomial regression, polynomial part, right? So now we are just continuing the polynomial regression part. So here, so we are facing the what the in that multiple linear regression. So we are just facing the 3D diagram, okay? The same concept, the linear equation, the linear graph, and the multiple linear graph. That is the same part. But point is what? This one is the 2D picture, and that one is a 3D picture. All right. And here we are just plotting that line, and then that case we are just plotting that plane. Okay. Okay. So if I just moving towards that that 4D diagram, then that part is nothing but the hyperplane, you can say. All right. So whenever just I'm explaining all about that multiple linear regressions, then I just explain all about that. Okay. So if like having any doubt, you can just move towards that video. Right. So here, what will be happen? So here means here polynomial regressions will be help you out to like create the best fit line, okay, for this case. So simply if we're just moving towards the simple polynomial regression, okay, so only simple linear regression, the line will be look like this. So now let discuss about this one. So if I'll just draw this line like this, then what type of problem will become? Okay, the problem will be what? So come to this part. So this is the what? This is the gap in between the actual. This one is what? Actual value. So this line is what? Predicted value. Okay, this one is the predicted variable. So now if we'll just find out the difference, okay, if we'll just find out the difference part. So here difference is nothing but the what? This one is the error. So now just tell me what is the error? So error is very high. Error will be very high, but our aim is why we're just drawing this line, because to means like to minimize the error, okay, to predict for each and every data set, and it will give them minimal error, okay, minimize error. So now next point is what? Listen, next point is what? So now we'll just what we have to try to bend this line. Okay, this is the linear line. So we don't need any linear line. We need a what? Non-linear line. Because this concept, okay, this graph is nothing but the non-linear. This graph is nothing but the non-linear. Now we have to just draw the line so that it will what? For the each data, it will be what? It will be slowly, it will be like a what? Minimize the error. Now if we'll just go to the error part, now the error difference part is very high, very high. All right. So now if you will listen, if you will here polynomial regression is coming with the 1 degree concept. Okay, means in the first case what will be happen in the simple linear regression? Simply we are just writing y equal to mx plus c, okay, or else y equal to v star 0 plus beta 1 x. If there is having one feature, then you are simply just writing. But have you ever think about that linear regressions and the multiple linear regression? So linear regression and multiple linear regression. So whenever just you are writing anything, so okay, so the highest degree is what? Highest degree is always 1. Remember one thing, so the highest degree is always 1. So that's why the line is like this. But what have you ever seen that quadratic equation diagram? So how it is looking like? Yes. So the quadratic equations diagram. So if I will listen, if I will just simply just improve that degree part, means the degree part. Okay. So the line will be drawn like this. The line will be drawn like this. So this is the quadratic part. So now just tell me. So is this in this diagram? So the error is what? Minimize or not? Yes or no? Means if you're just moving, means if you're asking about that equations, so here y equal to beta 0 plus beta 1 x, okay, so plus beta 2 x square, okay, so like this. The as you will listen. So I need up to x square is this one best fit. So if we'll just increasing continuously, this means the degree part, the line will become, the line will be drawn like this. Okay, so for each data, it will be drawn like this. So this is the problem of what? Overfitting. This is the problem of what? Overfitting. Okay, this is the problem of what? Overfitting. So this concept will become what is the overfitting and underfitting. So in the next video, I will explain it properly. Okay, so don't be confused. But think that, so this is the problem of overfitting. Right? So we need one line. So that line is what? That line is also eligible to predict the upcoming new data. So here we're just drawing what? So this red line is nothing but what? We are just drawing while taking this present data. But what about that future, means upcoming data? So that here this green color line, what? This is the best line. Whereas if any data will become, okay, because the data is coming in this form only. If any data will become, the error will be what? Very minimized. Okay, so if we're just moving, means here in this overfitting case, the training model is accuracy is very, very high. But what about the test accuracy? So we are not care about the test accuracy. So that's why, so in this case, we have to just solve this problem. Right? So as you just increase the degree, okay, you can just write in the polynomial regression, as we just increase that degree part, then the overfitting problem might be come in our front. Right? So this is the polynomial regression. So hope I just explained very clearly, and maybe I just show you the clarity part. Okay, so this is the difference between the simple linear regressions and the polynomial regression. So why I'm not taking that multiple linear regression? Because as you know that the implementation part of the linear regression, that one, so better it should be go for that simple part. Okay, the small portion part. So simple linear regression is nothing but the small portion part. Okay, right. So now you have to just practice all these things, and you have to take some of the example from the net. Okay, so you have to just practice a lot. Okay, we'll just do all these things like practically, so I need some time. So that's it, and thank you, bye bye. So we'll just meet in the next video. So if you like my video, so please do like and subscribe and share to with your friend. And also, if you're having any doubt, whatever things I just explained, you can just give me a comment. And if you need like a notes, anything, okay, so you can just simply just join our Telegram group, and that group link is already given in our like description part. Right? So that's it, and thank you, bye bye.